Alright, so we're going to go ahead and get started with the screencast for objective number 5. You're going to predict the products of radioactive decay reactions given the reactants and the type of decay that they undergo, and you're going to synthesize illustrations of complete transformation chemical equations. Basically, you're just going to be writing the transformation reactions. This is where you're actually going to be applying what we have kind of talked a little bit about with beta particles and alpha particles. So how are nuclear reactions written? That is your essential question. Anytime radiation is given off, anytime there is anything that's coming off, we say that's decay. Or anytime radiation or radioactive energy is absorbed, we say that is a capture. But either way, whenever you have decay or a capture happening, we have a transmutation that is happening. So you are literally mutating into a different element. Not you, the original element we started with. So in a decay emission, the radiation is going to be on the product side. So that's what I show you down here. This is a decay because it's on the product side. In a capture transmission, the radiation is a reactant. So here I have it as a reactant. In this case, carbon is going to lose an alpha particle, and in this case, americium is going to gain a beta particle. So here is my, just kind of some basic equations for you to look at. Another thing that you've got to keep in mind, and this is a way to check yourself, the sum of the mass numbers of the reactants must equal the sum of the mass numbers of the product. So basically your numbers on top on both sides of the equation must be the same. And the sum of the atomic numbers of the reactants must equal the sum of the atomic numbers of the products. When we go through a few examples in class, I'll actually work through this more with you. So the reason that I don't have this in presentation mode is because I want to fill this in with you as we go. So alpha decay and capture, you're going to write this down so we can complete this together in class, but I'm going to go ahead and just fill in these blanks with you so you can get all of this information down. So an alpha particle is literally 2 protons and 2 neutrons. So because it's 2 and 2, it's going to have a mass of 4, and it has a charge of 2 plus coming from the 2 protons. So if something is going to lose an alpha particle, it's automatically going to lose 4 in its mass number. And it's going to lose 2 in its atomic number. So it is going to lose 4 on the top, lose 2 on the bottom, and it's going to become a different element because it loses those 2 protons. If something gains an alpha particle, it is going to go up by 4. The mass number is going to go up by 4, and the atomic number is going to increase by 2. So it's going to become a different element. Right now I'm going to switch over so that you guys can write these generic equations to the educations video that I made, and you can see this separately as a separate link. But I'm going to go ahead and play this for alpha decay right now. Alright, so this is the educations video that's going to go with the alpha decay and alpha capture. So I'm just going to work through a couple of problems for you so that you guys can see how this works. We are going to do more in class, keep that in mind. So I'm going to just write the generic equation for you so that you can see it. So you're going to be given the element symbol, you're going to be given the mass number, which is what goes on top, and you're going to know the atomic number because you know the element. If you are gaining an alpha particle or capturing an alpha particle, you are going to see the alpha particle on the reactant side, and so your top number is going to increase by 4, and your bottom number is going to increase by 2. So you see A plus 4, and you see Z plus 2, and you're going to have a new element. So that's the generic equation for the capture. The generic equation for the release, or alpha decay, is the opposite. You're going to start with your element, you're going to know the mass and the atomic number, but you're going to see the alpha particle on the product side. So that means this number is going to go down by 4. So your A minus 4, and your Z is going to go down by 2. So Z minus 2. So it's the opposite. You just basically have to remember when you add them and when you delete them, or when you subtract. So let's just work through a couple of the example problems that I gave you in your notes. I'm going to do one of each for you. I'm just going to go ahead and do uranium-238. So I have uranium-238, and I know uranium has 92 protons, so I'm going to put that number down at the bottom. So it said in the example, uranium-238 loses an alpha particle. So that means the alpha particle is going to be on the product side. So my top number is going to go down by 4 because I'm losing it. So 238 minus 4 is 234. My bottom number is going to go down by 2 and become 90. Well, that is now no longer uranium. If I look on the periodic table, that is now thorium. And that's how you would write the reaction. This is the decay of uranium if uranium would lose an alpha particle. Now the next one has radium, specifically gaining an alpha particle. So radium-226, if I look on the periodic table, radium has 88 protons. So I'm going to show it gaining an alpha particle. So in this case, instead of subtracting, I'm now going to add. 226 plus 4 is 230, and 88 plus 2 is 90, and I end up with a different isotope of thorium. So this would be thorium-230, whereas this one right here is thorium, the one on top is thorium-234. This one would be thorium-230, but they're both thorium. So that should at least get you started or give you some examples. Remember to leave room for more examples for us to do them in class. Okay, so I'm going to go ahead and go back to the PowerPoint right now so that you guys can see this. What I did was what's at the bottom of this slide. I wrote the generic equation for you, and I actually worked through the first problem and the second problem, the uranium-238 and the radium-226. We'll work through these two problems in class, and then this whole slide we're going to do in class. So make sure that you leave enough room for us to do practice problems within your notes. So now just a little bit about beta decay and beta transfer. A beta particle is different in the sense that it is not going to be a mass of 4 and a charge of 2. It has a charge of 1 minus. There is no mass associated with it because it's essentially an electron. It is formed from the decomposition of a neutron. And when you decompose a neutron, you actually end up gaining a proton. So when you go through beta decay, it's a little bit more complicated. You're going to, if you lose a beta particle, that means you are going to lose 1 neutron. So the number of neutrons lost, the number of neutrons lost is 1. So if you lose 1, the number of protons is going to go up by 1. So you are going to gain 1, and I'm going to go ahead and just write lose 1 here. So that's what happens when you have beta decay. So the mass number is going to end up staying the same, because if I lose 1 but I gain 1, it stays the same. But my atomic number is going to go up by 1 because I've gained that proton. Beta capture is the opposite. When you go through beta capture, the number of neutrons is actually going to go up by 1 because you have a proton that becomes a neutron. So you are going to lose your proton in that case. You lose the proton and you gain a neutron. So your mass number again is going to stay the same. If I get my mouse to work, it's going to stay the same. And the atomic number, instead of going up by 1, is going to go down by 1. So I'm going to go ahead and flip you to the EduCreations video for beta decay so you can watch that. And I've worked through some of the examples for you. This specific EduCreations video is going to take you through beta decay and beta capture. It's a little bit more confusing than alpha decay or alpha capture is, but still, once you memorize what happens, whether you're gaining a beta particle or you're losing a beta particle, once you memorize what happens, it's not as difficult to work through these equations. So the generic equation for beta decay, we'll just start with that one. Is you're going to start with your element again, so you're going to have the mass number and the atomic number and your element symbol. If you are going through beta decay, that means you're going to lose a beta particle. So it is going to be on the product side. And remember, when you lose a beta particle, you are going to lose a neutron. So you lose a neutron, but in the process, you gain a proton. So your mass number is going to stay the same. So whatever your mass number is, it's going down by 1 and up by 1, so your mass number is going to stay the same. But now the bottom number, because you're gaining this proton, it is now going to increase by 1, and you're now going to have a new element. If you go through beta capture, which is what we would call a positron at that point, it's the opposite. So you have your element, again, you know the A and the Z, and here's your element symbol, but you're going to gain a beta particle. And when you gain a beta particle, that is the same thing as losing one proton and gaining one neutron. So when you lose when you have this process happen, your mass number is still going to stay the same because you gain one and you lose one. But now your atomic number, because you're losing a proton, is going to go down by 1. So you're going to form a new element. So let's go ahead and work through just one example of each. And remember, leave space in your notes because we're going to work through more examples if you need them in class. So please remember to do this. I'm going to work through the first example where you are losing a beta particle. So if you're in your notes or you wrote this down, you have 241.95 and it's americium. And it tells you that it's gaining a beta particle. So plus a beta particle, which is a positron. So remember, when you gain a beta particle, your top number is going to stay the same. So I'm just going to go ahead and write that over here. But because I'm gaining a beta particle, that means I'm going to lose one proton. So 95 is now going to become element 94, and I don't have americium anymore, I now have plutonium. The next example gives you thorium-234. Yeah, thorium-234. So I have 234. If I look on the periodic table, thorium is number 90, TH. And in this case, because I'm losing a beta particle, I'm going to put it on the product side. And because I'm losing it, my top number is still going to stay the same. Because remember, no matter what, I'm losing one and gaining another in terms of protons and neutrons. So my top number is going to stay the same. But in this case, because I am going to be losing a beta particle, that's the same thing as gaining a proton. Because remember, a neutron turns into a proton. So 90 becomes 91, and I now have element Pa. So it just depends whether you are gaining or you are losing. You're doing the positron capture or you're losing an actual beta particle. It's just a matter of memorizing what happens in each one. All right, I'm going to go ahead and stop and go back to the PowerPoint presentation here. So at this point, you've done the generic equation. And I worked through these two examples, although if any of you noticed, there was a little bit of an error when I was talking. On the first example, I showed you it gaining. On the second example, I showed you losing, and I set it backwards at first, but that's okay. So here is our other examples that we're going to do in class. So the other two, you can do these on your own. If you're comfortable and you want to try doing them, that's perfectly fine. We will do them in class, so leave room. This whole page of 4 examples we will do in class. You will also talk to your table partners and write test questions, so make sure you leave room for that. This last page right here, you will work with a partner at your table and create a summary chart. Basically, you're going to make your own foldable comparing alpha, beta, and gamma rays. This activity we are going to do in class, but you need to leave room for it. So basically, after you write down your examples for beta particles or for beta decay and beta capture, you need to just leave the rest of it blank so that we can fill stuff in. So before class, watch the screencast. Write out your notes for objective number 5 using the Cornell format. Remember to summarize your notes. You don't need to write everything down word for word, but I would write down the examples. Take the short quiz on Edmodo and answer the discussion question on Edmodo. This last slide before it cuts me off is a list of what we're going to do over the next 2 days in class.